let's think about the results of the lab from yesterday, Wednesday, with the push-pull stations lab. We saw all the information and the students answered the questions on each piece of paper, but we didn't get a chance to wrap up. Do that now. In all three cases, whether it was hooks being pulled, rubber stumps being pushed together, or magnets being pushed together without contact, this pattern emerged that there was a mirror image between the force versus time graphs for object A and object B. Whether it was equal effort pulling them apart or pushing them together, or if you tried to do unequal effort, holding one firm and working the other one, it didn't matter. It was a mirror image, and answering these two questions here, what's similar about the forces and what's different, it's at the crux of the matter here. What's similar is the strength of the forces are always equal. So this is hand drawn, but this peak here might be a plus 10 newtons, and this peak down here occurring at the exact same moment would be a minus 10 newtons. So the 10 newtons is the strength of the force, the magnitude of the force. The negative sign indicates the direction. So we can say what's different about the forces is their direction of these forces are opposite to each other. And this is true at any moment in time, all the time. Please turn to page 35 of your packet. This lab gives us the essence of Newton's third law, and let's fill in these blanks here to see Newton's third law stated completely. Two objects interact. There are two forces, one force on each object, which are equal in strength and opposite in direction. And an example, which anyone can do, and I would be doing in class if I were there, is say Mr. Mannix pushes on the door. If that force exists, then according to Newton's third law, there also must be the force of the door pushing on Mr. Mannix. These forces are simultaneous, which means they occur at the same time. Now, this law is known as the law of action-reaction, which you might have heard, and that's good to know that we're talking about this law, but watch out, action-reaction might make you think one force happens and then the other happens. Not true, they happen simultaneously. So here's a riddle for you, and there's not many riddles in physics. How are forces like shoes? Think about what we've just talked about, and you might come up with the answer. Right, are you ready? Here's the answer. There's actually similarity in three ways. Like forces, or like shoes, forces come in pairs of equal size and point in opposite directions. That's a good one, isn't it? All right, and that's the end of this.